Okay, so here's how you should have done those practice problems following the steps that I gave you. Remember, the first step is you put the first element in the center unless it's hydrogen, so we can do that. So I'm going to put carbon in the center, put everything else around it. Again, it doesn't really matter where you put them as long as you put them around it. Then we're going to count our valence electrons. I have 4 valence electrons from carbon, plus I have 2 hydrogens that each have 1 valence electron, plus 6 from the oxygen. That's going to add up to 12 valence electrons. I connect everything to the center. I complete the octet on the atoms around it. Hydrogen doesn't want an octet, so I'm only going to add 6 electrons to the oxygen. I'm going to count how many valence electrons I've drawn. 2, 4, 6, 8, 10, 12. So I don't have any electrons left over. So now I'm going to go count how many are on my center atom. Well, I only have 2, 4, 6 around the carbon, so I'm going to have to share some of my outer electrons with it. Only oxygen has outer electrons to share, so I'm going to take a pair from the oxygen and I'm going to share with the carbon. And then I get something that looks like this. If I look at the carbon, it now has 2, 4, 6, 8 around it, which means it has a complete octet, and so my Lewis structure is complete. Okay, let's look at the next one. Here I have NH3, so I'm going to put nitrogen in the center. I'm going to put my hydrogens around it. I'm going to count my valence electrons. I have 5 from the nitrogen. I have 3 hydrogens that each have 1. Well, this adds up to 8 valence electrons, right? So I'm going to attach this outside electrons to the center. I'm going to complete the octets on the outside, but hydrogens don't complete, so I don't want to add any more. I'm going to count how many valence electrons I've drawn. I have 2, 4, 6. I'm going to subtract that from the 8 I have. I have 2 extra valence electrons, and I'm going to put that in the center as a pair. Okay, I'm going to check my center atom. It has 2, 4, 6, 8. Since it has 8, we're good to go, and that's it. Okay, on the next one, again, I'm going to put the nitrogen in the center, and I'm going to put the hydrogens around it, but this time I have 4 hydrogens to go around it. I'm going to count my valence electrons. I have 5 still from the nitrogen. My 4 hydrogens each come with 1, but then it has a +1 charge. That means it lost one of its electrons. So I'm going to subtract 1 over here. So I now have 8 valence electrons. I'm going to attach all of these hydrogens to the nitrogen with 2 pairs of electrons. Again, I'm writing it as a dashed line. And then I have this. I count how many electrons are around the nitrogen. 2, 4, 6, 8. It's 8, which is what I wanted. And so this is the right Lewis structure, except for, because I have a charge, I'm going to put brackets around this Lewis structure and put the +1 outside, so everyone knows it lost 1 electron. Okay, the last one, the carbon dioxide here. Let's look at this. We have carbon in the center, the 2 oxygens around it. I have 4 electrons, valence electrons from the carbon, and my 2 oxygens each bring 6 valence electrons. That's going to add up to 16 valence electrons. I'm going to attach the oxygens to the carbon. I'm going to complete the octets on those oxygens by adding 3 pairs. I'm going to count how many electrons I've drawn. 2, 4, 6, 8, 10, 12, 14, 16. I don't have any extra electrons to put on that center atom. So now I look at the center and it only has 4 electrons around it. So I need to steal some electrons from the outside. I have 2 oxygens I can steal from. It doesn't matter which one I steal from here. So I'm going to steal from 1. And that gives me this structure right here now. However, we're still not done. The carbon only has 6 around it. So now the question is, okay, do I steal another one from this oxygen, or do I steal one from this oxygen now? Okay, I'm going to show you both of those options. I can steal one from here, or I can steal one from here. So if I stole one from the first oxygen, I would get a structure that looks like this. If I stole from the second one, I would get a structure that looks like this. And the question is, which one of these is correct? That's actually what we're going to be talking about next, is how can we tell between these two which is correct? And we use a method called formal charge. So let's go and look at formal charge.